Hello, in today's video I will be talking briefly about IPv4 addresses. I will mostly focus on subnetting in future videos. If you like my videos, please subscribe to my channel on YouTube and my Facebook page, CCNA Free Practice Labs. Now, we are talking about the IPv4 classes, and the classes are Class A, Class B, and Class C. Here we call these classes unicast. A unicast transmission stream sends IP packets to a single recipient on a network. And we have also Class D, and this we call it a multicast traffic. Why? Because multicast transmission sends IP packet to a group of hosts on a network. And also Class E, this class it's reserved for future experimental purposes. Now, what is an IP address in simple terms? An IP address is a label which is used to identify one or more devices on a computer network, such as the Internet. It's comparable to a postal address. An IP address is a long number written in binary. These routers or gateways are often configured to assign local IP addresses to the devices that are connected. IP addresses resides in layer 3 of the OSI model, and it is a connectionless protocol. Now, IPv4 addresses are 32 bits written in dotted decimal notation. For example, this IP address here, we have octets. It consists of 4 octets. Each octet is 8 bits. IPv4 addresses has a hierarchical structure to enable routing between networks, the network portion and the host portion. Now we will start talking about Class A. A Class A network number uses the first 8 bits of the IP addresses as its network part. The remaining 24 bits comprise the host part of the IP address. Its binary range from 0000 to 127.255.255.255. Now, the first octet on the left always starts with a binary 0 in Class A. 0 is reserved for the default network, so we cannot use this as in Class A, and or we cannot use it. 127 is reserved for loopback. So the actual range for Class A starts from 1.0.0.0 to 126.255.255.255. The first octet in binary in Class A starts with a 0 followed by 7 zeros, and this is we are talking about the first octet and to this binary number, as you can see. But here the actual range for a Class A is from 1 to 126. And here the first octet on the left is the network portion, and the the remaining 24 bits on the right are the host portion. Now, Class A network address, as we said, it 8 bits. This is for the network portion, and 24 bits. This is the host portion. For example, this IP address, this is for the network portion when you see it, and you can tell this is a Class A, and this is a host in the same network of 10.1.2.3. This is the network portion here, 10.0.0.0, and this side of the network this is the host portion of 10.1.2.3. Class A network starts from 1 to 126 on the first octet on the left. Now Class B, the first bit is in the first octet on the left starts with a 1, and the second bit is a 0. First octet in binary 10, and then it starts with a 1 and then a 0, or you can tell that the second bit on the left octet is for Class B is a 0. And this is in binary and decimal is 128 to this binary number, and this is equal to 191 because the second bit on the left on the first octet is a 0. Now, so the binary range for class B is from 128.0.0.0 to 191.255.255.255, and this is the network portion, and this is the host portion in class B. Now, class B network addresses, as we said, they are 16 bits network portion, and like this is when you read this 172.16.0.0, this is the network portion, and the other 16 bits are for the host portion, like this same IP address 172.16.1.1. This is the host portion, and this is how we write the network portion in binary. And here, this is how we write it also for the host portion in binary. The class B network starts from 128 to 191 on the first octet on the left. Now, class C, the binary class C starts with 11 or 11, sorry, not 11, followed by a 0, or the third bit is a 0 in class C on the first octet on the left. The first octet in binary, as you can see, 11, then the 0, 2, 110, and this is how we write it in binary, and in decimal it's 192 to 223. The binary range for class C is 192.0.0.0 to 223.255.255.255. And the portion, and we have the host portion. This in green is the network portion for class C, and the remaining 8 bits or the octet on the right, this is for the host portion. Class C network address, it's a 24-bit for the network portion, and this is an example of a class C 192.168.1.0, and the 8-bit is for the host portion, because as we said, we have IPv4 addresses are 32 bits. And this here, when we read this IP address of 192.168.1.1, this is the host portion. And this IP address in binary, this is how we write it for the network portion, and this is how we write the IP address for the host portion, as you can see. Now, class B network starts from, sorry, I meant to say class C here, from 192.223 on the first octet on the left. This is a typo here. This should be a C. Sorry about that. Now, class D, the first octet in binary starts with 111 followed by a 0, or the fourth bit from the left is a 0 in class D. The first octet in binary, this is how we write it, 1110, 000 to 110 and 1111. This is the last one. So this is in decimal 224 to 239. Now, class D is a multicast address. Now I'll explain a little bit about a multicast. Why is a class D used for multicasting? Class D is reserved for multicasting. In multicasting, data is not destined for a particular host. That is why there is no need to extract host addresses from the IP address. And class D does not have any subnet mask. This IP class is reserved for experimental purposes, only for R&D or study. Class D addresses are used for multicasting applications, unlike the previous classes. The class D is not used for normal networking operations. Multicast IP routing protocols are used to distribute data, for example, audio or video streaming broadcasts to multiple recipients. Using multicast, a source can send a single copy of data to a single multicast address, which is then distributed to an entire group of recipients. Now, class C, the first octet in binary starts with a 111 followed by a 0, or the fifth bit on the first octet on the left is a 0. And we write it like this, 111 followed by 4 zeros, or the fifth bit is a 0 to 111, and this is the rest is 111, and in decimal 240 to 255. The range of class E addresses from 240.0.0.0 to 255.255.255.255. This is the broadcast address. Class E was set aside for experimental use.